Hello my dear students, in this video now we are going to learn what are heterocyclic compounds and how these are named. The cyclic compounds which contain nitrogen or oxygen or sulfur or silicon or phosphorus atoms in the rings in addition to carbon atoms are called as the heterocyclic compounds. In this picture we can see some compounds like benzene, naphthalene, cyclopentadiene, and anthracene. Here, all these rings or cycles are made up of the only carbon atoms. Other atoms are not present. So that's why these compounds are known as the homocyclic compounds. Otherwise, we can call them as the carbocyclic compounds. Homocyclic, or we can call them as the carbocyclic compounds. Here in this picture we can see some compounds whose rings are made up of carbon atoms and other atoms like nitrogen, oxygen, sulfur are also present. This one is pyrrole, furan, thiophene, pyridine, pyrimidine, 1H pyrrozole, 1H imidazole, 1,3 oxazole, and benzofuran. Here, along with carbon atoms, other atoms are also present. So now we can consider them as the heterocyclic compounds. These are some general heterocyclic compounds. Some compounds are not considered as the heterocyclic compounds even though they contain other atoms like nitrogen, sulfur, phosphorus, and oxygen, because they easily undergo hydrolysis and rings are broken and they change into the chain compounds. So that's why they are not considered as the heterocyclic compounds. So the unstable compounds which can be easily converted into open chain structures are here not considered as the heterocyclic compounds. And examples for this type of category compounds are lactones and lactams and anhydrates. Lactones are nothing but cyclic esters. Here in lactones we have the C double bond O linkage, and we know very well that when esters are hydrolyzed they change into the alcohols and carboxylic acid groups. And second example for this category is lactams. Lactams means nothing but cyclic amides. So amide means CO. The compounds which have the CONH functional group in them are called as the amides, and cyclic amides are known as the lactams. So when lactams are hydrolyzed, we get the amine group and a carboxylic group. And third one is the anhydrates. So anhydrates on hydrolysis gives the carboxylic acids. So here cyclic anhydrates give the dicarboxylic acids. So that is the difference. So all these unstable compounds which can be easily converted into open chain structures are not considered as the heterocyclic compounds. Now we go for the nomenclature. Here, three types of nomenclatures are in practice for the heterocyclic compounds. First one of them is the trivial nomenclature. Second one is the Hantzsch-Widman nomenclature. Third one is the replacement nomenclature. Here, trivial means not so important. So these are some common names. As these are very easy compared to the systematic nomenclature, sometimes we use, not sometimes, many times we use these names because these names are very comfort to use. But these names have no importance because they are not systematic. So that's why we call them as the trivial names. And here we can see some compounds: benzofuran, indole, benzothiophene, benzofuran, and 2H isoindole, and benzothiophene. Here also we can see some more compounds with trivial names: ecridine, carbazole, quinoline, and isoquinoline. For the same compounds, we go for the replacement nomenclature as well as the systematic nomenclature. Some more compounds are shown here: pyridine, pyridosine, pyrimidine, pyrazine, pyrazole, and imidazole. In Hantzsch and Widman nomenclature, each name is made up of the three words. They are the prefix, stem, and the suffix. Here, the word prefix indicates the heteroatom present in it, and stem indicates the ring size, and the suffix indicates whether the compound is saturated or unsaturated. Here, so now we go for the list of prefixes. For the oxygen, we use the prefix oxa. For sulfur, we use the prefix thio or thia. For the nitrogen, we use the prefix eza. For selenium, we use the selena. For tellurium, tellura. And for phosphorus, phospa. For silicon, sila. For arsenic, arsa. And for germanium, germa. And for boron, bora. Here, now we go for the words that are used for these stems and suffixes. If the ring size is 3, we use the word ir, and for the 4 we use the 8, and if the ring size is 5, that means for the 5-membered rings, heterocyclic rings, we use the word ol as the stem word. And if the compound is unsaturated with nitrogen, for the 3-membered heterocyclic compounds, we use the word ene. So I replace in irene. And for the compounds without nitrogen also, we use the same word. And for the heterocyclic compounds with ring size 3, if they contain nitrogen atom, we use the word iridine. And for the saturated compounds with three three atoms in it without the nitrogen atom, we use the word ane. So E replace N, irane. So like that we follow the table and we give the names. Here for the heterocyclic compounds with the ring size 6, the stem word is in. And for the heterocyclic compounds with the ring size 7, it is it. If the ring size is 8, we use the OC as the stem word. And depending on the situation and saturation or unsaturation, we use the related suffixes and we give the names. For example, if the compound is 8-membered heterocyclic ring and it is unsaturated and it contains nitrogen, we use this ocyne. And for the compounds without nitrogen also, we use the same word ocyne. OC plus ine, ocyne. And if it is a saturated compound and contains nitrogen atom, when we use the word ocene. And if it is a saturated compound without nitrogen atom, we call it as the ocane. So this is the table we have to follow while giving the systematic nomenclature for the heterocyclic compounds. And by using this table, we try to give names for some heterocyclic compounds. Here, these two are the 3-membered heterocyclic compounds. Here, so for 3-membered heterocyclic compounds, the stem word is ir. And here it is oxygen is the heteroatom, and here nitrogen is the heteroatom, and both are saturated. So for the saturated, we would use ane. Sorry, ane. And for the saturated compound without nitrogen atom, we would use ane. So here it is the heterocyclic compound without nitrogen atom. So we would use irane, oxirane. Oxygen is the prefix, and ir is the stem word, and ane is the suffix. So the name becomes as oxirane. And here prefix is eza, and ring size is 3, so we use ir. And as it contains nitrogen atom, we would use idine, so the name becomes aziridine. The name becomes aziridine. So these are the three-membered heterocyclic unsaturated compounds. So for this one, prefix is oxa, and as it is a three-membered cycle, we use ir, and as it is unsaturated without nitrogen atom, we would use ene. So without ene, so we would use ene, oxirine. So for this one, prefix is eza, and stem word is ir, and it is an unsaturated compound with nitrogen, so we would use this one plus ene. So the name is azirine. Here instead of I, we would use e, azirine. 1H is in. So as the hydrogen is present on the nitrogen, we have to call it as the 1H azirine. This is saturated, this is unsaturated. Heteroatom is phosphorus, heteroatom is phosphorus. So both these are phosphorus heterocyclic compounds. So for both these compounds, we have the phosphor as the prefix, phosphor. And as they are three-membered rings, we would use ir. And for the saturated compounds without nitrogen atom, so these two are for the saturated compounds. For the saturated compounds without nitrogen atom, we would use ane. So for the this is unsaturated, no? So for the unsaturated one, we would use ene. So this is ane, and for this one, we would use ene. So phosphirane and phosphirine. So these are the two names for these two compounds. And these two are also sulfur heterocyclic compounds with ring size 3. So the prefix is thia or thio. Thia plus ring size is 3. So prefix and stem word is same for both these compounds, and these are compounds without nitrogen atoms. So ene and ane we would use. So for saturated one, we would use ane. For unsaturated, we would use ene. So thyrane and thyrene. So these are the two names for these two compounds: thyrane and thyrene. So while joining the words, we have to remove the O. We have to remove this O, and while writing the thio plus ir plus n. So while joining these words, we have to remove this O. So the name becomes thyrane. And for this compound, it becomes thyrene. And here we can see some four-membered heterocyclic compounds. So these two are oxygen heterocyclic compounds. So prefix is oxa, and stem word is ete. And for these three, prefix is eza, and stem word is ete. And for this saturated one, we have to use the saturated, we have to use ane. So ane. So now it becomes oxetane. And for the unsaturated, we have to use ete. So oxide. So as the hydrogen atom is present at the second position, we have to call it as 2H oxide. And this is saturated with nitrogen atom. So we have to use this one. so it is becomes agitidine. And this is a heterocyclic compound, unsaturated heterocyclic compound with nitrogen, and unsaturated with nitrogen, so we would use this one. So the name becomes 2H azide. So dihydro, sorry, 1 comma 2H, so 1 and 2, so 1 and 2 dihydroazide. Now 1 1 2 3, and it becomes the 2 comma 3 dihydroazide. These are some heterocyclic compounds with the sulfur and phosphorus. As the ring size is 4, the stem word is eat, and for the sulfur atoms we would use thio as the prefix, and for the unsaturated for the saturated one we would use n. So thio plus eat, so thiete plus n, so it becomes thietane, so it is a thietane. And for the unsaturated one, so 1 2 3 and 4, so it becomes 2H thiete. And for this one, phosphor plus eat plus n, so phosphitane. We combine them, we would remove this one, and it becomes phosphitane. And now it becomes 1 comma 2 dihydrophosphate, 1 comma 2 dihydrophosphate. Now here we can see some 5-member heterocyclic compounds with the oxygen atom. So as these are oxygen heterocyclic compounds, we would use the word oxa as the prefix. So oxa as the prefix, and so we would use unsaturated and saturated, so without nitrogen. Yes, oxa plus, so we without nitrogen atoms, no, so we have to use this one and this one. Okay, so oxa plus stem word is ol, so ol plus, for the unsaturated one use n, so it is oxolene. Oxa plus ol plus n, oxolene. So we would remove this one, so oxolene. And now it becomes unsaturated with nitrogen, so we would do this one, so it becomes oxol. That's all, it is oxol. And here 1 2 3 4 and 5, so hydrogen atoms are present at the second and fifth position, no, so it is 2 comma 5 dihydroxol, so it is unsaturated one, so we have to use ol, so 2 comma 5 dihydroxol. Here we can see 5-member heterocyclic compounds with a nitrogen atom. So these two are unsaturated and this is saturated, so we would use this one and this one. So as nitrogen atom is present, then we have to use the eza as the prefix, eza plus stem word is ol. Okay, and for the saturated with nitrogen we would use olidine, so idine, so we have as idine, so now it becomes azolidine. Okay, that's good, it is azolidine. And for the unsaturated one, what we would use unsaturated one, so we have to follow this one, no, so it is azole, aza plus ol, azole, so it becomes azole. the trivial name for that one is pyrrole, but the systematic name is azole. Is and for this one, how we have to name 1, 2, 3, 4, and 5. So it is derived from here, no? So it is considered as the reduced compound of the azole. So that's why we give the name as the 2,5 dihydroazole. 2,5 dihydroazole. These are the heterocyclic 5-member heterocyclic compounds of the sulfur atom. As the sulfur is the heteroatom, we would use the word thia. And for the 5-membered ring, same word is ol. And so this is saturated, so we would without nitrogen, so we would use this one. And these two are the unsaturated compounds without nitrogen atom, so we would use this one. Okay. So for the saturated compound, we would use ane suffix. So we have to remove this one. So thiolane. Okay. Now it becomes thiolane. Thia plus O, ol plus N, thiolane. And for this one, thia plus ol plus it is unsaturated without nitrogen. So okay. So ol. So it is a thiol. That's it. Thia plus ol, thiol. Okay. And for the name for this one is 2,5 dihydrothiol. Okay, that's good. 2,5 dihydrothiol, because it is considered as the reduced form of this one. In this picture, we can see some heterocyclic compounds of phosphorus with 5-membered ring size. As the heteroatom is the phosphorus, we would use the phosphor as the prefix, and ol as the stem word. And for the unsaturated one, we would use, without nitrogen atom, we would use ol suffix plus e. And for the saturated one, we would use ane. So this one is phospholane. Okay, that's good. It is phospholane. And this one is phosphol. Sorry, here hydrogen is there at the first position, so we are called as the 1H phosphol. 1H phosphol. And this one is considered as the reduced form of the 1H phosphol. No? So how we have to name 1, 2, 5 trihydrophosphol. We can give the name like this: 1, 2, 5 trihydrophosphol, or 2, 5 dihydro 1H phosphol. Either way we can call it as. And here the 6-membered compounds with oxygen heteroatom are present. So as the heteroatom is oxygen, we would use the prefix oxa. Okay. And for the 6-membered ring, in is the stem word. And for the saturated one, we have to use ane. And for the unsaturated one, we have to unsaturated without nitrogen atom, we have to use ine. So now it becomes oxa plus in plus n, oxinane. Oxinane. Simple, here the name is written in a wrong way. Actually it is oxinane. Simple oxygen means water. So it is wrong. Sorry. And this one is known as the this one both are named as the oxy plus in, oxins. So these two are known as the oxins, but here hydrogen is present at the second position, and here hydrogen is present at the fourth position. So that's why this one is known as 2H oxine, and this one is known as the 4H oxine. Okay. And here we can see some compounds of nitrogen with ring size 6. So as a heteroatom is nitrogen, we have to use the word eza, and for the 6 member we would use in. So we have to use follow this word, this and this. Okay, so for the okay, for the sorry for unsaturated one, for the saturated one there is no special word. Saturated compounds here are considered as the reduced form of the unsaturated compound, so there is no special suffix for the saturated heterocyclic compounds of nitrogen atom. Okay, so for the unsaturated one, look here, for this one first of all we have to give the name. So Aza plus ine, so it becomes as azine. Aza plus, we would follow this one, no? So Aza plus ine, azine. So for the pyridine, actually the common name or trivial name for this one is the pyridine, no? So the systematic name for pyridine is azine. Systematic name for the pyridine is azine. And other compounds are here considered as the reduced compounds, so that's why we give the reduced names for these compounds. Okay, so in this one, hydrogen is present at the first and fourth position, no? So that's why it is considered as the 1,4 dihydrogen, and this is considered as the 1,2 dihydrogen, and here each atom is attached to the one hydrogen atom, no? So that's why it is known as the perhydroazine. So like that we give the names. And these are some heterocyclic compounds of sulfur with ring size 6. So for the ring size for the sulfur heteroatoms we would use the word thia. For 6 member we would use in. Okay, and for the saturated one we would use in. So we would remove this one, thionine. So thionine, and for the saturated one we would use thia plus in, thioine. So thi plus in, thioine. So like that we have to give the name. And hydrogen is present at the 4, so that's why it is a 4H thioine, and it is a 2H thioine. These are some heterocyclic compounds of phosphorus with 6 member ring size. So that's why that the prefix is phosphor and in, and also phosphine. So its name is plus n, so phosphine. And for the unsaturated compound, phosphor plus ine, phosphine. So and hydrogens are present as the 1 and 4 position, we call it as the 1,4 dihydrophosphine, and this is known as the 1,2 dihydrophosphine. So like that we have to give the names for the 7 membered compounds also. So try to give the names on your own. Okay, practice on your own. And these are some heterocyclic compounds of the ring size 7 with the nitrogen atoms. So try to give the names on your own, practice well. So these are some phosphorus heterocyclic compounds, and these are some sulfur heterocyclic compounds with the ring size 7, and to try to give the names on your own. These are some boron heterocyclic compounds, try to give the name on your own, practice well. And now we go for the third category of the nomenclature, that is the replacement nomenclature. Here in this replacement nomenclature we consider the heterocyclic compounds as the compounds derived from the known compounds. For example, here this pyridine is considered as the compound derived from the benzene, so that's why we call it as the azabenzene. Comparing with benzene, we call it as the azabenzene. And this one is given as the phosphobenzene, and this one is a thiabenzene. because these are considered as the product obtained from the benzene. Okay, and here we can call it as the benzopyridine, benzo B pyridine, because here it is attached with the B position, no? So that's why B benza B pyridine. And look here, it is A, it is B, it is C. You can, so we call it as the benza C pyridine. So we can consider them as we can consider these two compounds, we can consider these two compounds as the products of the benzene or the products of naphthalene also. So if we consider them as the products of naphthalene, we can give these names. One is a naphthalene and two is a naphthalene. But the trivial names for these compounds are quinoline and isoquinoline. Quinoline and isoquinoline. Okay. And here perhydrofuran here is considered as the product of the cyclopentane. This is known as tetrahydrofuran. No, commonly it is known as the tetrahydrofuran, THF. It is considered as the product of the cyclopentane. So that's why we give the name oxacyclopentane. Oxacyclopentane is the replacement name of the tetrahydrofuran. Tetrahydrofuran is the uh, trivial name or systematic name. And Hantzsch-Widman name for this one is oxa plus ol plus n, so it is oxolane. So systematic name for this one is oxolane. Okay, and cyclobutane, and it is thiacyclobutane, cyclopropane, azacyclopropane, cyclo, we know the cyclohexane, no? So this is 5 phosphocyclohexane, phosphocycloheptane. So these are some replacement names. Thank you for watching. Thank you.